now that we've kind of walked through a lot of these geometries and given a basic structure for how to identify them, let's walk through the THC molecule. And I know I have the line structure here, which is eliminating a little bit of information. But we can identify a few spaces here and then pull them out because there's similarities. There's a lot of the sameness within this. For example, all of these ones I'm going to highlight blue. These are all going to be carbons that are bonded to just 2 hydrogens. And then we have a number of carbons that are bonded to 3 hydrogens. I'm going to highlight these. We also have a number of carbons that are bonded, have double bonds. So they're right here and right here. And we have a few oxygen. Let's get a different color for them. Remember, we're only interested in the ones that have multiple things bonded to it. So there's one more I want to highlight. There are these, there are a few carbons that are bonded actually to 3 carbon without a double bond, and they're right here. And then we have one that's bonded to 4. Sorry. Just really kind of like the one's bonded to hydrogen. It's really about the number of things, not what the things are. So let's kind of walk through these different shapes and I'll blow them up. So any of these ones here, where I have a carbon bonded to another carbon and then 2 hydrogen, are going to look like this. And so because there are 4 things bonded to it and 0 lone pairs, this is going to be a tetrahedral carbon. All right, let's look at one of these ones that would have 3 hydrogens bonded to it. We would have a carbon bonded to another carbon, and so that's this one here. So I can actually highlight that to show it. And then it would be otherwise hydrogens. And so again, this carbon doesn't have any lone pairs. Carbon rarely has a lone pair. And so it tends to form these tetrahedral geometries quite a bit. So if I look at this again, it has 4 atoms bonded. It has 0 lone pairs. And so this will be tetrahedral as well. And so that'll be the same geometry at any of those points in this molecule where the carbon is bonded to those 3 hydrogens and then another carbon atom in the molecule. Let's look at this oxygen right here. So this oxygen is bonded to 2 carbons, and it's going to have then 2 lone pairs. And so this is going to have 2 atoms bonded to it and 2 lone pairs. And so this is going to be that 4 shapes. They're all going to be 109 apart or 105, something like that, similar to these ones over here. But it's going to have a different name because there's just 2 atoms in those spots. And so we're going to call that bent. All right, let's look at a different one. Let's look at one of these that are yellow that have a double bond. And so here we have a carbon that is double bonded to a carbon bonded here to an OH, to the oxygen, and then to another carbon over here and another carbon here. And this one has a, so we could look at either of these carbons and they should have the same geometry because they both have a double bond and then bonds to 2 other atoms. So they each have 3 atoms bonded and 0 lone pairs, no electrons around those carbons. They're on the oxygen, but that's not the atom we're looking at. And so these are going to be separated by 120 degrees, and it'll be trigonal planar. Okay. That's covering a lot of it. We have just one more type left. Let's do it over here. Here is a carbon that is bonded to a lot of carbons, actually. And then one hydrogen. So here, let's get this labeled. This again has 4 atoms bonded to it, 3 carbon and 1 hydrogen. It has 0 lone pairs. And so we're going to use the geometry name of tetrahedral. And this will have that bond angle of about 109-ish. And so when we look at the structure of THC, we see that we have a lot of tetrahedral carbons for geometries. We have 2 bent oxygens, and then we have a handful of carbons that have a double bond to it at some point around it, and so have a trigonal planar geometry.